Hey guys, what's up? Welcome back to Study Bubbly. Today we're doing another physics podcast. This is Unit 1, where we're also going to cover pre-unit stuff, such as vectors, as you see on the screen, even though, it's not a Unit 1, but we're still going to cover it. Dove, do you want to lead?
So let's start off with frame of reference. It's an observer's point of view, and it requires a coordinate system to set the origin. Vectors are quantities, or a property of a material or system that can be quantified by measurement, that has both magnitude, distance, quantity, size, or speed, and direction. It's basically a directed line segment that looks something like this.
Think of quantity as value. Magnitude and direction describes vectors. You need to have like a direction. So this would be like northeast, right? That's north and that's east. So that would be, let's say, 5 meters. That's the basics for vectors. We're basically going to go through practice problems because it's one thing knowing this like the terms and stuff, but practicing it is a little bit different. So each of us have a few questions that we can go over and that sort.
And also just like in general, you can find like most of the information on our notes, so there's no point in us
Right,
just
right.
going over it again.
One thing you do need to know is that you can move vectors in whichever direction. So let's say John went 5 meters to the east, right? And then he went 10 meters to the north. He went 5 meters back. If you just look at that, and sorry for the handwriting, this thing lags. Um, but in the end, he went from here to here. So his final vector would look like this. That's like where he moved. Just noting that vectors, you can move them around in any direction as long as like the head is touching the tail. Let me do another example to better illustrate this. 5 meters, 10 meters. Let's say John went crazy and he went to the right 5 meters, right? So um, in this example, his displacement would be this. And that looks horrible. So what we want to do is we're going to like reorder it. As long as it's touching, it doesn't matter what order you do it in. So let's say this is 1, this is 2, this is 3, right? So you can line up 1 and 2, 1 and 3 like this. So this is 5 meters, 5 meters. This is 1, this is 3. And then you can put 10 meters like that. This 1, 2, 3, that's just my way of telling you which of these it is. And so the final vector would be like that.
Clarifying, you can add all of like the verticals, vector x's, and all of the horizontals. This is horizontal and this is vertical. You can just add like, for example, 5 meters, 5 meters, and then this would be 10 meters. You can do it this way and doesn't matter which one comes first.
I have a few practice problems we can do shortly. So first one, this one's more conceptual. So there's an A vector. It goes in this direction. There's a B vector. Goes like that. Okay, so which represents the direction of A minus B? So answer choice A, B, C, D. A is this, B is this, C is this, and D is this. Okay, so for subtraction, you're basically adding the negative, remember, right? Vector A is northeast, vector B is also northeast, but pointing a little bit to the north. So answer choice A is to the right, answer choice B is to the left, C is northeast, and D is farther down northeast. Okay, so we're going to subtract B from A. So if you remember from what we were saying previously, that if you're adding vectors, you basically add it. If you're subtracting vectors, you
Whoa.
switch the sign. If you're subtracting vectors, you switch the sign of the second one, so it's a negative. And remember, if you're switching, A is like this, right? It's pointing northeast. So B right now is also pointing northeast, but what we want to do is we want to switch it 180 degrees. That's the other way around, right? So it would look like this. So remember how we were talking about having the tails and the heads together? So like that and like that. Heads Well, we didn't talk about this, but now we're going to talk about it. When you're adding vectors, you have, for example, you have this line and you have this line. The third line would not be this. The third line would be tails and heads to heads.
If you're given like vector, for example, this is A and this is B. If we want to find the displacement, it's just we have to go from this point is the tail and this is the heads. You would think that you want to go this way, but like in reality, you actually want to go the other way to find
Yeah, right,
just like
right.
direction.
Okay, so this one is a purely text one, so I can just read it out loud. So two vectors, A and B, have the same magnitude m, but vector A points north, whereas vector B points east. What is the sum of A plus B?
Also, in this case, since there's only two and you're not given like a number, you can just add them together. And then the displacement be just this.
Right, right.
And if you're given like numbers, you can use the Pythagorean theorem to figure out how much
Well, you were
displacement is.
given numbers thing.
Oh,
You
well, I
what?
didn't. Okay.
I thought you
You were
said
given
the same
m.
magnitude.
Yeah,
Oh,
both are m. So what's d? Because remember, if both of them's n, that means it's a isosceles thing, right? So
oh yeah.
this is 90 degrees. That means that and that is 45. Okay, so that means it would be m square root of 2 because 1 square root 2. Okay, so the answer is m square root of 2 northeast, which is what you guys put. All right, great. Okay, moving on. If a vector A equals I minus 2j, vector B equals 4i minus 5j. Remember, the ij is another form of xy. Remember? It was a long time ago. I think I is horizontal and j is vertical. Yeah, I think it's that.
Yeah.
Anyways, what angle does A plus B? Well, think of it as x and y. It's the same thing.
Okay, so similarly, it's the same thing basically, but in this case, it's just using I and J. So you can just do vector I as one of them and vector J as the other one. And since you see the first one has 1i, the second one has vector B has 4i, you can just add that up, which is 5i in total. And then for vector in the J direction,
Right.
you have -2 and -5. You add those together, you get -7j. And basically your magnitude vector, I think they usually use R, is basically just 5i and -7j.
I finished the question, but I didn't give the answer choices. Okay, so
Yeah.
it's asking the angle that A plus B forms. So we know it's 5i, right? Minus 7j.
I is the x direction.
All right, so we need to find the angle that this makes. You have to use SOHCAHTOA because the answer choices for this. Yeah, theta equals tangent -1 3/5. B is theta equals tangent -1 7/5. And the last C and D are theta equals sine -1 3/5 and theta equals sine -1 5/7. So first of all is which one should we use? R is the hypotenuse, so it's not sine, it's not cosine, so it must be tangent.
Well, actually, no negatives because you can't have negatives. The negatives just tells you the direction for.
Right. Yeah, that's the answer.
So yeah, like what we said before, two-dimensional vectors just involves more complex vectors, such as vectors in the x direction, vectors in the y direction, and sometimes you're given these really weird vectors that are like 36 degrees north of east. So what you would do in this case is you would actually want it to split it into two vectors, the x direction and the y direction, because that just makes things a lot easier.
Right. We do this a lot in unit 2 when we talk about the ramp stuff, but you still need to know these now.
Anyways, like I was saying, you're given whatever this number is x, and you just use more trigonometry to figure out whatever this is and whatever this is to find like the vectors if you want to add it to, like, for example, another vector that's this way.
I.
It
Oh
has
my
this
god.
angle.
Okay. All
What
right.
if it
If
like
they see
goes
this kind of,
this way?
and then they go this way.
Right. It splits into 2 at this point. Okay. Great. All right. Just noting a few things. If you remember Shadow's racetrack from the notes. If you don't, go check those out.
Pretty
It
cool.
explains it explains it explains distance and displacement. I'm kind of tying this into unit 1 because we need to go there soon. So with that also comes with speed and velocity. So there's these few things that are very similar but are not the same. So displacement is the net distance, velocity is the net speed. So keep this in mind because later on it's might get confusing.
Relative vectors are more like slightly more complex vectors because they require you to like figure out, like, for example, car is traveling this way and a second car is traveling this way. Essentially, a problem would be like asking you what would be the motion of the yellow car or green, I guess, green car in relation to the blue arrow vector car.
Okay. Huck Finn walks at a speed of 0.7 meters per second across his raft, perpendicular to the raft's motion relative to the shore. The heavy raft is traveling down Mississippi River at speed of 1.5 meters per second relative to the river bank. So the raft is traveling 1.5 meters per second. Gotcha. What is Huck's velocity, speed, and direction relative to the river bank?
Okay, so you're given a special equation for this type of problems. So essentially, what it is basically V of AC is equal to V of AB plus V of BC, essentially. So because it's all relative to each other, so you have to use this equation.
Right.
And so in Huck Finn's case, as we can see in my so beautifully written work,
Okay, Dev.
I labeled it as H, which is Huck, B, which is the riverbank, and R, which is the raft. So essentially, since you're trying to figure out what is Huck's velocity relative to the bank, you're trying to figure out V of HB, which is equal to the sum of V of HR, which is Huck relative to the river, plus the river relative to the bank. And you basically use just more vector addition since it's 0.7 meters north and
Tell me if I'm wrong, but in my opinion, this looks exactly like a vector problem. Like with
yeah,
this being that and this being that. So you're kind of basically rewriting this to this and that and putting that there, right?
essentially, yeah.
So it's 0.7 and then river current is 1.5. So it's finding this one, right? Finding the hypotenuse of 1.5 and 0.7.
Yeah.
Okay. Yeah. Just making sure.
Well, it's kind of like the I and J thing. They gave us like
Yeah.
equations for that, but like you don't really need them.
Yeah.
Yeah.
Yeah. All right. So we're going to separate the pre-unit with the units so it doesn't drag on too long. So yeah.